Oppan Gangnam Style. Gangnam Style. Oppan Gangnam Style.
Hey everybody, what's up? We are going to go over really quickly something we were going to do earlier this week, actually Wednesday, but I decided to kind of drop that and spend most of the day, or most of the last half of the day, looking at giving you some individual work time for that electron transfer process, that assignment. Um, but for today, what I want us to look at is just how to write. It's basically an introduction to how to write names and formulas of these ionic compounds. Now, I know you already did that on the ion formation assignment where you transferred the metallic electrons to the nonmetals and you were able to write a formula and a name. But there is a way to make the formulas and names a little easier than writing out that big old mess of arrows with electrons. Now that's good for explaining why the formulas and the formulas are what they are and how electrons get transferred. But there is a faster way to do this. And so that's what we're going over today. And there is a discussion post on today's Power School page that you need to fill out or at least add to for participation points for today. So I do suggest jotting this stuff down though, okay? Because I want to come into class Monday already understanding what's going on, and then we just kind of move on from that. All right. So in order to write the formulas and names of an ionic compound, first, you need to make sure that you have a metal and a nonmetal in your compound. Now again, metals are on the way all, on the left side and the middle of the periodic table. All right. Metals are your cations, nonmetals are your anions. So the positive charges are in the beginning of the compound. The second part of the compound is your anion. Those are mostly your nonmetals. Plus things called polyatomic anions, which we'll get to later. The formula is written so that the charges balance out. All right. Everything in life is about balance. Okay. I guess in Star Wars, the balance of the Force. I guess that's something too with the Jedi and the Sith or whatever. Everything's about balancing. So if you have like two positive charges in your compound, you need to have two negative charges to balance it out. It's just how it works. You need your periodic table with ion charges. All right, so the one that we filled out earlier this week, you need that. So keep that open either from your notebook or on a document somewhere. So I want to go over three particular examples of how to write the name and the formula when you combine two certain ions. So we have three different examples, but you can do really any metal with any nonmetal in the periodic table as long as they have a charge, and it should work. So let's say for the first one, we're combining sodium ions and oxygen ions. So the question is, what's the formula and the name when sodium bonds with oxygen? And we're not going to draw the arrows this time. We're just going to look at the charges of the two ions to see how it's going to work. So here's where we need your periodic table. So get that out, and we're going to look at the charges. Sodium and oxygen. Sodium and oxygen. Let's take a look. Sodium is right here. Its charge is +1. Oxygen is right there. Its charge is -2. Okay. So what I want to do is write that out. So sodium ions, I'm going to do Na. I'm going to write a 1 plus or a +1. That's the charge of sodium. And for oxygen, I'm going to write O2 minus because the charge of oxygen is -2. So these are the charges of the ions. But up here, the formula is written so the charges balance out. So right now the charges aren't balanced. By balance, I mean they need to be the same. Okay, think of a seesaw. If you have a 200-pound person on the right and a 100-pound person on the left, it's not going to work. It's not even. All right, this person's going to stay down, this person's going to stay up. You need to balance it out somehow. So think about what you can add to balance it out. Well, I have two negatives for oxygen. I need another positive for sodium to balance it out. I need to add another sodium ion to balance out the charge. 2 minus Now we have two pluses. It's even. So note that you didn't have to draw out that transfer process diagram. You could just use the charges here. So the formula for this compound of sodium and oxygen bonding together is Na2O. You need two sodiums and one oxygen for the charges to cancel. And the name of this is sodium oxide. So the first element, the metal, is just the metal itself, sodium. And the second part is the nonmetal or the anion. That's where you change that ending. Again, table salt is sodium chloride. It's not sodium chlorine. That's not a thing. That's just two elements. But here we have two ions, the sodium ion and the oxide ion, sodium oxide. And there we go. So it's all about balancing those charges out. That's one example. Again, the beauty of video is you can pause and rewind and fast forward whenever you want. So do that if I'm going too slow or too fast, up to you. Aluminum and fluorine. Now for aluminum and fluorine, if I look back at my ion charges, aluminum is a 3 plus, so I'm going to write 3 plus here. And fluorine is a 1 minus. I'm going to do F 1 minus. And again, just check above your ion charge table. You'll see it there. Plus 3 minus 1. We're not even yet. We need to get even. So that's where you got to make sure that your positives and your negatives are evened out so they cancel each other out. I need to add more fluorines. Don't add more aluminum because you have 3 plus and you have 1 minus here. So if I add another fluorine that's closer, I have 2 minuses. Let's add another one. 3 minuses. 1, 2, 3. 1 aluminum ion, and I have 3 fluorine ions. Plus 3 minus 3, I'm canceled out. Hey. So here's where my formula comes into play. My formula is always the metal first. I got Al. I only have 1 aluminum, so I just leave it as Al. I have 3 fluorines here. 1, 2, 3. So I go AlF3. Remember Alf? He's back in POG form. AlF3. There we go. 1 aluminum, 3 fluorines. The name of this, again, we just named the metal first, aluminum or aluminium if you're from Europe. The second element is fluorine, but we end them always in "ide." The ides have it. So aluminum fluoride, that is this compound. Cool. Again, if I'm going too fast, rewind. Hit me up with an email, though, if you need another little explanation. But I feel like these visuals work pretty well. We're just trying to make sure that our charges balance out. That's the whole, all of chemistry is about balancing things out. Okay, that's the majority of it, making sure that things are even. Oops. All right. Magnesium and nitrogen. So on my P table, magnesium is a 2 plus. It's on the left side, and nitrogen is a 3 minus. So the 2 plus and the 3 minus, or the 3 plus and the 2 minus, these ones are a little bit iffy. They take a little bit more time because it's harder to get them to even out. But with enough practice, you'll understand how it works. We have 3 minus charges and 2 positive charges. So I add another magnesium. We're now at 4 positive charges and 3 minuses. Well, that's not going to work. I need to add another nitrogen. Oh, now I'm at 6 negative charges and 4 positive charges. Well, let's just add another magnesium. 6 positives, 6 minuses. There we go. So that's how many ions we need in the formula. So the formula of this would be Mg. We have 3 of those ions. N2. We have 2 nitrogens right there. The name of this is magnesium nitride. You end it in "ide, and we're good. So it's all about, again, I've said this many times, it's all about balancing the positives with the negatives. The easiest ones are when it's like +2 - 2 or +1 - 1 because they already cancel out. That's why NaCl is so common and so nice. Sodium's a +1, chlorine's a -1. NaCl, sodium chloride. All right. So last couple things here, and then we're going to be good to check out your discussion post. Transition metals are really weird because they don't have a distinct charge to them. And we talked about this a couple days ago, but when we did the charges, I only gave you charges for these particular groups. Alkali metal, alkaline earth. We skipped all of these guys. I want to box these ones in. We skipped all of our transition metals. Okay, all these guys, plus a couple more like over here. They're still popular. They still have charges. It's just that the charge varies. Okay? They don't it's like they can't decide what to eat for dinner. It's like sodium always if sodium's always a +1, it always wants spaghetti. Okay? Aluminum's always a +3. It always wants stir fry. But iron, it sometimes wants stir fry, it sometimes wants steak, it sometimes wants chicken parm, it sometimes wants Wendy's. It doesn't know. It's always changing. And so given a formula, we can figure out what the charge is. And that's what we're going to look at now for a couple minutes. It's not going to take too long. It's actually not too bad. Transition metals can have multiple possible charges. So in the formula FeCl3, what is the charge of the iron ion? Well, let's try to figure it out. So if we look at the formula, we have one iron and we have three Cl's. So I'm going to draw that out. We have Cl, Cl, Cl. Well, in the P table, we know that chlorine's charge is a -1. It's always a -1. It always eats pasta for dinner or whatever. Iron, it depends. So we can figure it out, though, by using what we know here. So from all these chlorines, that equals -3. Okay? Like we've talked about earlier, charges have to balance. It's a fact. It needs to happen. So if all of the chlorines add up to -3, and we only have a single iron here, the charge has to be +3. No way about it. Has to happen. If it's a +2, it won't be balanced. If it's a +1, it won't be balanced. +4, it won't be balanced. So the +3 is the only way to make it work in this compound. And if we look at our last example here, CuO, what is the charge of the copper ion? Well, we can do the same thing. I can write out Cu, that's copper, and I can write out O, which is oxygen. There's only one of each. And on the periodic table, oxygen is always a 2-. All right, it always eats, it always eats roast chicken for dinner. It never varies from that. And so the only possible charge for copper is a 2+. Because oxygen's got a 2-. There's only one of the oxygens in the formula, and the only way to balance it out is if the copper is a 2+. Cool. So check out that discussion post. Revisit this video if you need to. I may have gone too fast or too slow, depends. But we're going to revisit these things coming up in the following week. But you need to be at least familiar with this because I'm not reteaching all this stuff because this is all on here. Okay, we got a couple more things to do before finals. So take it easy, everybody. Adios. Goodbye.